homework time. Yes, happy homework time is here again. Let's start by jotting our name down at the top of the paper. I will put my name. You will put yours. And you put the actual date today. I'll just write today. It's good to put a good heading on your paper. Our instructions are for each of the following: time yourself for 1 minute. See how many multiples you can write. So multiples of 5 starting from 75. So multiples are, the easiest way to think of it is skip counting. Okay, so we're going to start from 75 and write down multiples of 5. So our next one would be 80, right? Okay, we're supposed to time ourselves for a minute, so go. Probably a lot faster than me. All right, I'll stop whistling, fine. Yeah, da 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 da. Oh, that's just as bad? All right. Da 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 da. Yeah, da 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 da. You see how it works, though? Yeah, okay. And, oh yeah, I still got some time, okay. Da 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 da. Da 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 da. 5. Almost there. Okay. I'm looking at the clock in case you're wondering. Yeah, all right, so that's a minute. All right, so now let's do multiples of 4 starting from 40. This is going to be a little more interesting. You might actually have to think now and then. So we'll start by writing 40, boom, comma, and go. Okay, that's a 4, really it is. All right. 52. Let's see if I can discern a pattern while I'm doing this. 56. 60. Oh, okay, yeah, so 60 is going to be just like 40, because then it'll be 64, 68, see, 44, 48, and then 72. Yeah, I'm just kind of talking to myself. You don't need to, we're just writing multiples of 4. I'm going to space out at some point or write something incorrectly. I know it. Almost there. 6, 100. Almost. Okay, that'll do it for 4s, and now multiples of 6 starting from 24. So 24 is where we start from. Skip counting by 6s, go. Oh, all right, yeah. Oh, see, there's a pattern here too. See, like 54, just like the 24 where we started. Yeah, you see how it works? 66, 72, falling asleep, 84, about halfway there, 90, oops, got messy, I was looking at the clock, 96, oh, you gotta think a little here, right? Yeah, okay, 102. Almost there. Almost there. Last one. Okay, that's a minute. Okay, so that's done. Let's run away. Run away to the next example. Run. Happy, good. Good. No more lists of numbers to do. List of numbers that have 30 as a multiple. Okay, so this hopefully is not too much of a mind bender for you, but the numbers that have 30 as a multiple. Okay, so in other words, the numbers that when you are skip counting, you will hit 30. Okay? So now think about it. Let's just start with, well, what it's going to be. It's going to be the factors of 30. Doesn't that make sense? That all the factors of 30 will have 30 as a multiple. For example, 1 will have 30 as a multiple, right? Because when you're skip counting by 1s, you're going to hit 30. All right. 2 is a factor of 30, isn't it? Because when you're skip counting by 2, multiples of 2, you're going to hit 30, aren't you? And now let's kind of do this in the rainbow fashion. Hopefully I didn't even leave enough room. So, 30 is going to have 30 as a multiple, right? That's the first one, yeah. And 2 times what? Well, 15, right? 15 will have 30 as a multiple, won't it? Yeah, 15, 30, 45, 60. Okay, so we'll hit 30 there. And then what else are factors of 30? Yeah, you're right. 3 times 10, right? So we can add 3 and 10 to our list. See how I said I'm doing a rainbow fashion, going back and forth with the factor pairs, but putting them in order at the same time. So if you skip count by 3s, 3 has 30 as a multiple, right? So this is the crossover. This is like the Venn diagram middle section of factors and multiples in our minds that, hey, it's the factors of 30 that have 30 as a multiple. So they're different things, but there is this connection between them, obviously. So, and then, of course, we know that 5 times 6 is also 30, which is to say that 5 is a number that will have 30 as a multiple. 5, 10, 20, 5, 10, 15, 20, 25, 30. There it is. Okay, and 6 will as well. 6, 12, 18, 24, 30. They all have all of these numbers. These are the factors of 30. And yes, those are the numbers that have 30 as a multiple. So when we look at this next one for number 3, we can use mental math. Hey, mental means we don't have to write anything. Division, or the associative property to solve. Use scratch paper if you like. We won't need any stinking scratch paper. Is 12 a multiple of 3? In other words, if you're skip counting by 3, are you going to hit 12? 3, 6, 9, 12. Yes. And to write a proof of that, we could just simply write, hey, yeah, 3 times 4 is 12. So is 12 a multiple of 3? Yes. If I count by 3s 4 times, see, times 4, 4 times, I will hit 12. So yes. So then is 3 a factor of 12? Yes, it is, right here. Look, factor times factor equals product. Yes. So yes, it is. So it's going to be, if one of these is true, the other is automatically true, isn't it? Yes. Okay, so if it's yes, it's going to be yes, and if it's no, it's going to be no. So is 48 a multiple of 8? Well, if we skip count by 8s, are we going to hit 48? 8, 16, 24. And if you don't know this offhand, you can look at a multiplication chart. 32, 40. Yeah, there. 48 would be the next one. Yes, 40, then 48. Because 8 times 6 is 48. So yes, 8. If I skip count by 8s 6 times, I'm going to hit 48. So 48 is a multiple of 8. Multiples of 8 are 8, 16, 24, 32, 40, 48, and so on. So again, the answer is yes. Is 48 a factor of 8? Oh, they switched the question around, didn't they? See, now this is one I bet a lot of kids are going to get wrong. Eureka! Because you would expect this question would be, is 8 a factor of 48? Which would be yes, right? But no, they switched the question around. Is 48 a factor of 8? In other words, is there a whole number that you can multiply 48 by, some number, to get 8? No, there isn't. Circle slash. That is not mathematical. That's me goofing around. So, no, is 48 a factor of 8? No, it's not. 8 is a factor of 48, but not the other way around. Ooh, those little. Okay, so is 56 a multiple of 6? Well, if you're skip counting by 6s, are you going to hit 56? So let's skip count by 6s. 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Oh, well, look. see 56 is right here between them. And yeah, we did not hit 56, skip counting by sixes. So 56 is not a multiple of 56. So then is 6, and this one is stated in the same way that A was, in the way you would expect, is 6 a factor of 56, which is asking, can you take 6 rather, and multiply it by some number to get 56, some whole number? No, you cannot. So again, my non-mathematical circle slash, that does not work. So this is also a no. So can a prime number, here's another brain bender for us. Man, they're making us go crazy tonight. Can a prime number be a multiple of any number except itself? Explain why or why not. So let's take an example of a prime number. Let's take something like 19 as prime. Its only factors are 1 and 19. So 19 is a multiple of itself, right? Because that's the question, part of the question we were asked, and 1. Yeah, so it can be a multiple of any other number except itself. Yes, in fact, every prime and all prime numbers we can make this generalizations are multiples of one and themselves. I get a feeling that that was not the answer they were looking for, that they were looking for us to say, no, it's only a multiple of itself, but it is a multiple of 1. You know, all whole numbers, all positive whole numbers are multiples of 1. So, it is a multiple of both 1 and itself. And using 19 as an example, we could use any prime number, and it just by definition of a prime number will be true. So can you believe we're almost done here, rounding the corner already in homework time? But number 5 has a couple parts to it, I think. Let's take a look. All right, and in number 5 we start off here with this cute little table and a series of instructions. So we're to underline multiples of 6. So multiples, again, we can think of as skip counting. When a number is a multiple of 6, what are the possible values for the ones digit? Okay, so we actually noticed before when we were doing this that there was a pattern, right? Okay, so 6, 12, 18. Multiples are just skip counting. 24, 30, 36, 42, 48, 54. If I'm going too fast, let me know. 60, 66. Slow down? Okay. 72, 78, 84, 90, 96. Okay, and then the next one would be 102. So this is just a little glimpse of the beauty of mathematics. You see the pattern here? 6, 36, 66, 96. When you go down the columns here, 18, 48. Oh wait, these were 30 apart, and these are 30 apart too. 18, 48, 78. 30, 60, 90. 12, 42, 72, 24, 54, 84. They're all 30 apart. Isn't that interesting? So the question, though, is what are the possible values for the ones digit? Well, here it's a 6. Then it's 2, 4, 6, 8, 0. In fact, if you look on this diagonal here, 2, 4, 6, 8, 0. 2, 4, 6, 8, 0. 2, 4, 6. And then the next ones, if we extended it, would be 8 and 0. Okay, so the answer is, what are the possible values? Well, it's going to be 2, 4, 6, 8, or 0. That's the answer. Let's look at part B here. And in part B, we're to draw a square around multiples of 4. Then look at the multiples of 4 that have an odd number in the tens place. What values do they have in the ones place? Well, let's go ahead and draw our little squares around multiples of 4. So 4, remember multiples just skip counting. 8, and we're going to encounter this a few times, right? We're a crossover between 6 and 4. 12, 16, 20. There's going to be a bunch here. 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64. You see the patterns developing already? 68, 72. You could probably do this without even really skip counting by 4 at this point and just follow the pattern, right? So the next one, yeah, we go from a 2 to a 6, right? So 76, but we'll skip count. 80, 84, 88. Just getting that 6 underline reinstated there. 92, 96, and 100. Those are all the multiples of 4. So if they have an odd number in the tens place, so that would be all of these. 12, 32, 52, 72, 92, right? And then this column, 16, 36, 56, 76, 96, they all have odd numbers in the tens place. And these do not, and these do not. What values do they have in the ones place? Well, 2, these all have 2 in the ones place, and these all have 6. So it's either 2 or 6. Exclamation point. Which I shouldn't write because it has a mathematical meaning that I do not intend. All right, but let's go look at 5C, see what treasures it has in store for us. And in part C, we are now asked to look at the multiples of 4 that have an even number in the tens place. Okay, so we won't look at 4 and 8 because they have nothing in the tens place. So they're here, 24, 44, 64, 84. And then 28, 48, 68, 88, 20, 40, 60, 80, 100. Okay, what values do they have in the ones place? So they have, in the ones place, we have a 4, and here we have an 8, and we have a 0. So our answer to that first question is 4, 8, or 0. In the ones place. Do you think this pattern would continue with multiples of 4 that are larger than 100? Well, you can actually kind of continue this. You can look at this hundreds table here, right? And say, okay, next would be 104. So it would be like here, right? And then 108. 112. After 100, it would look exactly like this, wouldn't it? Yes, it would continue. So, yes, the pattern would continue. And it doesn't ask us to explain why, and it would, but we can understand it, why the pattern would continue, because the pattern of the number system itself continues. Yes, the pattern would continue. Boom. All right, so that's C. Let's take a little look at D. Yeah. And in part D, we are to circle multiples of 9. And then choose one, any one, I guess. What do you notice about the sum of the digits? And we'll choose another one. and answer what do we notice about the sum of the digits. So multiples of 9 we're going to circle. Okay, hopefully you know how to skip count by nines. If you don't, grab multiplication table. 9, 18, 27. Oh, do you notice something happening here? 36. Do you see even just the way we're traveling? See? Isn't mathematics beautiful? 45, 54. 9 times 7 is 63. 9 times 8 is 72. 9 times 9 is 81. Cool. Now choose one. What do we know about the sum of the digits? Well, take 18. 1 plus 8, sum of the digits is 9. 2 plus 7 is 9. 3 plus 6 is 9. 4 plus 5 is 9. 5 plus 4 is 9. 6 plus 3 is 9. 7 plus 2 is 9. 8 plus 1 is 9. And if you notice as well, the tens place, if we consider this a 0, which it technically isn't, but 0, 1, 2, 3, 4, 5, 6, 7, 8, and of course next would be 9. And then in the ones place we have 9, 8, 7, 6, 5, 4, 3, 2, 1. Nines are cool, huh? The sum of the digits of the multiples of 9 is 9. So that's what we notice in both cases. That answers both questions. The sum of the digits of the multiples of 9 is 9 itself. Now, would that continue? Well, there's a little question to boggle your mind. Would it continue once we get past 81 and once we get past 100? What about when we get up into, like, deep into the hundreds, like into the 200s and such? I wonder what would happen then to the sum of the digits of the multiples of 9. Well, that will be an adventure for another time. Perhaps the next time it is, again, homework time.